Hi everyone. Today from class 9, chapter 5, Introduction to Euclid's Geometry, we are going to study about a concept that is equivalent versions of Euclid's fifth postulate. So equivalent versions of Euclid's fifth postulate. What is that fifth postulate? I have already explained to you in the introduction part. Still once again we can revise that. The fifth postulate says that if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angle is less than two right angles. This I already explained to you in the introduction part. What does it say? It's very easy. Just see. If there are two lines are there, and a third line falling onto that. So when it is falling onto that, there forms a interior angles, both the side. Here also interior angles, this also is a interior angle. So both the side it forms the interior angles. When these interior angles are formed, we have already studied that the sum of interior angle is 180. That we have studied in the smaller classes. But this fifth postulate says, when two lines are there and a third line falling onto that, and the interior angle that is formed, one side of the interior angle will be less than 180. And which is that side? The side where if we produce these two lines indefinitely, it will somewhere intersect or it will meet somewhere. So that side, the sum of the interior angle will be less than 180. I hope you are getting my point. So the fifth postulate says, so when two lines are there and a third line falling onto that, the interior angle, the side where if we produce indefinitely, if we extend this line, this will somewhere meet this line. So that side, the interior angle will be less than 180. So that's what we are trying to tell in this fifth postulate. So now coming to the equivalent versions of Euclid's fifth postulate. So there are several equivalent versions of this postulate is there. One of them is Playfair's axiom by a Scottish mathematician John Playfair in 1729. So there are several equivalent versions for this fifth postulate is there. So one of them we are going to see, that is Playfair's axiom. So let's see what is Playfair's axiom. So the Playfair axiom says, for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. Don't get confused, very easy. For every line L, so here we have the line L. Here. For every line L, so let me make it darker for you. For every line L, so this is your line L. For every line L and for every point P. So here you have a point P. Okay, so for every line L and for every point P not lying on L. So this P, this point is not lying on L. It is outside the L line. So for every line L and for every point P not lying on L, there exists a unique line M. So this is the unique line. So there exists a unique line M passing through P and parallel to L. See, you can see here in this point P, there are many lines are passing through. Okay, so you can give any name to this line. So any line passing through this point P. But there is one unique line that is called M. So this unique line M, only that line is parallel to this line L. So this is what Playfair's axiom says. For every line L, for every point P not lying on L, there exists a unique line M which passing through P and parallel to L. So that means just trying to tell, so through one point many lines are passing through, but there will be only one line which can be parallel to the other line, in short. So now from there we can also say that two distinct intersecting lines cannot be parallel to the same line. So if you see here, two distinct intersecting lines, so you have intersecting line, so it cannot be parallel to the same line. So this cannot be parallel to the same of to this line, neither this can be parallel to this line. So two distinct intersecting lines, so two distinct intersecting line cannot be parallel to the same line. So they can't be parallel to the same line. So this is not parallel to this line, neither this is parallel to this line. So they are not parallel to the same line, but one unique line which is parallel to the next other line, that is L. That's it called axiom, Playfair axiom. So mainly we studied here what is Playfair's axiom, and that is for every line L, for every point P not lying on L, there exists a unique line M which is parallel to L. That's the Playfair's axiom, and this is one of the equivalent version for the fifth postulate. That's it. Thank you. God bless you.